A quadratic inequality in one variable can be written in one of the following forms. So just there again, it gives you guys those different signs. So you have less than or equal to, greater than or equal to. So you can have 4 different inequalities. So when we're trying to solve a quadratic inequality, just like when you're trying to solve a quadratic equation, you have to make sure that your inequality is in standard form. But you guys can solve them using a table graph or an algebraic method. And I just like doing the straight algebra as a rule because sometimes the other methods incorporate the algebra, which is what you already needed to do. So it just sort of is less work to do it the algebraic way. But we can do, I'm going to show you guys all 3 methods. So the first one is using a table. So if we put our equation in standard form, we get x squared plus x minus 6 is greater than or equal to 0. So all we want to do is plug in each one of these x values and see what we get for y. So again, sort of periodically treating it as an equation. But when we plug these in, so like we would plug in negative 6 squared plus negative 6 minus 6, what does it equal? 24. So we would just keep going down lines. So if we plug in negative 5, we would get 14. Negative 3, I jumped ahead of myself, is 0. Negative 4, 6, negative 2, negative 4, negative 1, negative 6, 0, negative 6. So now we're going up, would be going up the other side of the parabola. 1, negative 4, 2, 0, 3, 6, and 4, 14. So symmetrical points, so that's fine. So if we're trying to look at the inequality that we're given, so that's what we always go back to, we have the inequality x squared plus x minus 6 is greater than or equal to 0. So we want the values that make that true. So we want the values that are greater than or equal to 0. So if we're looking at our table, values that are greater than or equal to 0 are this section here and this section here. So that section in the middle is no good. So if we were trying to write a solution for this, I can see that all the values that are negative 3 or less, or positive 2 and higher are going to work. So if I'm trying to write that in a solution, as a solution, it would be everything less than or equal to negative 3, so negative infinity to negative 3. There's a gap there, so that's where we use the u. And then it starts up again at 2 and is everything greater than 2. So infinities always get parentheses, guys, but based off of our inequality sign, which is right here, it's greater than or equal to. So we need to include those values of negative 3 and positive 2. So if you were trying to write it as an inequality, it would be x is less than or equal to negative 3, or x is greater than or equal to 2. So that's it. So just be careful if it's asking you to graph the inequality or if it's asking you to solve. If it's asking you to solve, you need to actually give me the interval that tells me these are the values that work for the inequality. These are my solutions. So just make sure you are careful of what it's asking of you. The second way to solve an inequality is by graphing it. So you would graph the parabola, find the shaded region, and then base your interval notation or your inequality notation statement off of the direction or the way that you shaded. So we just learned a bunch of ways to solve a quadratic function. We learned about factoring, completing the square, using square roots, and we also did the quadratic formula. So the quadratic formula is the one that works always no matter what form or what type of quadratic equation you have. If you can factor, I would, but in this case, what's going to end up happening is we're going to find the vertex, and then we're going to have to find the x-intercepts. We're going to have to find x, or solve for x. So let's find our vertex first. So x equals negative b, so negative 3 over 2 times a, which is 1/2. So negative 3 over 1 is negative 3. Find your y. So 1/2 times negative 3 squared plus 3 times negative 3 minus 2 equals, let's see, half of 9 is 4.5. Minus 9 is 4.5. Minus 2 is negative 6.5. So equals negative 6.5. So your vertex is negative 3, negative 6.5. So now we need 2 more points. And I'm going to make those 2 points my x-intercept. So we talked a little while back saying that when you're solving for x, it really means that you're finding the x-intercepts. That's what you're doing. So finding the x-intercepts, finding the real solutions, finding the zeros, the roots, it all means the same thing. So if I want to find the x-intercepts, all I'm doing is finding my 2 x values for the solution. So I can't factor this because of that lead coefficient of 1/2, and it just doesn't work. So if I'm going to solve for my 2 values of x, I'm going to have to use the quadratic formula. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b. So negative 3 plus or minus the square root of b squared. So 3 squared minus 4 times a, which is 1/2, times c, which is negative 2. Over 2 times a, so 2 times 1/2. So x will equal negative 3 plus or minus. 3 squared is 9. 4 times 1/2 is 2. So negative 2 times 2 is 4. So 9 plus 4 is 13 over 1. So I get my 2 answers, and I'm going to leave them as a decimal. I'm going to find the decimal because we're trying to find the x value on the graph. So if I add negative 3 plus the square root of 13, I get 0.61. So x equals 0.61. And if I subtract, I get x equals to negative 6.6 repeated. So I'm going to plot those 2 values on my graph. So negative 6.6 and 0.61. Now I can graph my parabola, and it is going to be dashed. So if I do a test point of 0, 0, I'll plug that in. I would get 0 plus 0 minus 2. So negative 2 is less than 0. So the inside is where I want to shade. So that shading tells you guys what your interval notation or inequality notation is going to look like. So we know our x values have to be between negative 6.6 and 0.61. So if they were shaded on the outside, you would have an or inequality, but because they're shading between, you have an and inequality. So to write this as your solution, you would write that x is in between 0.61 and negative 6.6. And it's just less than, so that's all you need there. And your interval notation would just be, okay, from negative 6.6 to 0.61. So inequality notation and interval notation. So that shading just shows you which way your interval or your inequality is going to look. Is it in between or is it on the outside? So the last way to solve is algebraically. And to me personally, this is just the way I like to do it. So if we're trying to solve, you still want to make sure it's in standard form. So if it's not equal to or greater than or equal to 0 on one side, you want to make it 0 on one side. So we want to subtract that 4 over. So we're going to make this x squared minus 3x minus 4 is less than 0. So now, you guys can always go right to the quadratic formula. I'm not stopping you from using the quadratic formula. But if you can factor it, I think that's the easiest way to go. Remember, that's one of your ways of solving. So I can factor this left side. I can make this x minus 4 times x plus 1 is less than 0. So again, periodically treat it as an equation. So if we use our zero product property, we could set each of these equal to 0 and solve for x. So we would get x equals 4 and negative 1. So what that tells you is where to put your dots or your points on your number line. So if we go down here, let's make this 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3. Okay, so we would have a point or a circle at negative 1 and at 4. So that is nothing new to you guys, and they're both open because they're not equal to, because our inequality sign is not equal to. It's just less than. But we do need to figure out which way to shade. So what you want to do is check each interval. So we need to check a point to the left of negative 1, a point in between negative 1 and 4, and a point to the right of 4. So I'm going to check negative 3, 0, and 5. So if I check those values, so I just plug them in. So I would get negative 3 squared is 9 plus 9. I get 18 is less than 4. That is not a true statement. So we're not going to shade to the left of negative 3. So it's or negative 1. It's not less than negative 1. So if I try 0, I get 0 squared minus 3 times 0, which is 0. So I end up with 0 is less than 4. And remember, you're plugging these values into your original inequality. So 0 is less than 4, so that's good. And then if we plug in 5, we get 25 minus 15, which is 10. So is 10 less than 4? No. So we're going to shade the section or interval that had the true statement when we check. So 0 made the statement true, so that must be the section where the solutions need to be. So you guys don't really need to check 3 solutions every single time or 3 sections every single time. It's either going to be an and or an or. So if you had checked that negative 3 value right away, saw that it was false, then you know it's not an or, you know it's an and. So you could have just shaded the middle right away. But that would be it. So if you guys are trying to write it as a solution then, it would be from negative 1 to 4, but we're not including it, so we give it parentheses. As an inequality, x is greater than negative 1, but less than 4. So that's it. So remember, if it asks you to solve, you're giving me a solution set or an interval notation. You're showing me or writing the solutions down for the inequality.